This video is going to be a quick introduction or brief introduction to using the double angle identities in trigonometry to simplify expressions. So here are our double angle identities. Sine of 2 theta is equal to 2 sine theta cosine theta. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And tangent of 2 theta is equal to 2 tangent theta over 1 minus tangent squared theta. And here's the first expression we're going to take a look at simplifying. Now, given the introduction, we know that we're probably going to use double angle identities, but regardless of that, it's a good idea to take tangent and turn it into sine theta over cosine theta in general. Or at least that's where I like to start. So sine theta over cosine theta times cosine squared theta. Let's go ahead and put that over 1. Plus cotangent, I like to again start with tangent and cotangent, turning them to sine over cosine, or cosine theta over sine theta times sine squared theta. And we're going to put that over 1 as well. Now, cosine theta and cosine squared theta will reduce to leave us with just cosine theta on top. And sine squared theta over sine theta will leave us with just sine theta on top. So our reduced expression so far will be sine theta cosine theta plus cosine theta sine theta. Now that doesn't really help. If we look at our double angle identities, it doesn't really match any of those so far, but if we reorder it to make this sine theta cosine theta, then you'll notice we have a repeat, sine theta cosine theta plus sine theta cosine theta, which means we really have 2 sine theta cosine theta, which matches one of our double angle identities, giving us our simplified expression of all of that equaling sine of 2 theta. Alright, here's one for you to try. Go ahead and pause the video, work it out, and press play when you're ready to see the answer. You may notice that 1 minus 2 sine squared theta is a typically given double angle identity for cosine, but we're going to use what we know in order to derive or prove that identity. Again, pause the video, work it out, and press play when you're ready to see the answer. Now to do this one, I'm going to do a bit of a trick, and it's going to be using our Pythagorean trigonometric identities, namely sine squared plus cosine squared is equal to 1. So we're going to turn 1 into sine squared plus cosine squared minus 2 sine squared theta. Now sine squared minus 2 sine squared is going to leave us with just 1 sine squared theta. And you'll notice that cosine squared minus sine squared matches our double angle identity of cosine 2 theta. So this is equal to cosine of 2 theta.